With this section, we are going to be looking at what's called separable differential equations. And so what that means is we have a function that's going to be consisted of more than one variable, and we're going to see if we're able to separate those variables and then eventually find the integral of those functions. So let's look at this example here. It says find the general solution for this following equation, and we want to express the solution explicitly as a function of the independent variable. So in other words, you can see here we have two variables going on here. We have an x variable, all right, and then we also have a u variable. So here we have this differential equation, right, u, that's consisted of the variable x. So we want to see if we can separate those two variables. Okay, so what we're going to do is get everything that has a u on one side and everything that has an x on the other side. So the first thing we can do is we can simply rewrite our right hand side of our function like so. Okay, so because we have this e raised to the 7x minus u, then since it's e to some power and we have this subtraction in the middle, then we know that we can rewrite it with multiplication in the middle, because we know if we multiply, then that means to add the exponents. Okay, so that's the first thing we're going to do. Now we want to, again, put everything that has a u on one side and everything that has a x on the other side. So what we're going to do is this e to the negative u, that's the same thing really as saying 1 over e to the u, right? So to get rid of that over here on this side, then we're basically just going to simply multiply both sides by e to the u, okay? Because if we do that, we can see that over here on the right-hand side, it's going to go away. So we're going to simply multiply both sides by e to the u. All right, and so now we're just left with 6 times e to the 7x over on the right side. Okay, so now that we have the variables separated, we now want to find the general solution. So that means we need to find the integral. So we need to find the integral of both sides. Okay, and we're going to do it with respect to x. Okay, so we want to put a dx there. And then same thing over here, integral of this side, and then again with respect to x. So what should we do then with this u prime? Okay, well, u prime of x, that's the same thing as really saying find the derivative of our u with respect to the x variable. So that means we're going to just simply rewrite this u prime x with du dx. So therefore, we have the integral of e to the u times du dx, and then we still have this dx here, so we're going to bring that down. And then over here, we're just going to just bring everything down. We haven't really done anything with this side yet, okay? Well, now, what do we have over here on the left side? You can see now those dx's cancel out. So then over here, we just have the integral with respect to u, okay? So you can see we have all u's on that left side, and then now over here, we can factor out this 6. And you can see we have all x's on the right side, okay? So we were indeed able to separate, right, that differential equation, okay? So this one is considered to be separable, okay? So now since it is separable, let's go ahead then and find the integral of both sides. So we know, of course, the integral of e to the u is just e to the u. Then over here, we have the 6 out in front, and then again, the integral of e to the 7x, right? That's just going to be e to the 7x divided by the 7, right? So remember, whatever is in front of that constant, you just divide by that. And then since this was an indefinite integral, we have to remember to say plus c. All right? Well, now, here remember it says to express the solution explicitly as a function of the differentiable or in the independent variable. So whatever is inside here, that's our independent variable. So we want to rewrite this in terms of x. So then what are we going to do then over here for this left-hand side? Well, we want to get rid of that e, right, so that we can eventually have this as a function u of x, right? That's what we want to try to get. So in order to get rid of this e, we know that we can just simply take the natural log of it, right? Because we know it's just the inverse of that. So then, of course, whatever we do to one side, we have to do the same thing to the other side. Okay, so we're doing the ln of both sides. Well, now over here, ln and e, they're just inverses of each other, so they basically cancel out. So we just left with u, okay? U is equal to the natural log of 6e to the 7x over 7 plus c. And now you can see we were able to get the u by itself. And over here, this is in terms of the function x, so that's explicitly, right, as a function of our independent variable, okay? So therefore, we can simply rewrite this now as a function u of x, right? That's our independent variable of just simply ln of 6e to the 7x over 7 plus c. And there we go. Okay, so we were able to get that function explicitly as a function of x. All right, so here it says now determine whether the following equation is separable, and then if it is, then we want to actually solve the given initial value problem, okay? So we know this is an initial value problem because we have this initial condition, okay? So that means we're going to use this to help us find, when we get to that plus c part, this is going to help us find the c, okay? All right, well, let's go ahead and see if this is indeed separable, okay? So what we're going to do is, you can see we have the y over here and the t, right? So we have two variables on one side. We want to see if we're able to separate those variables, okay? So put a y on one side, put the t on the other side. So what we're going to do is, to get rid of this y, we're just simply going to divide both sides by the y, okay? So when we do that, then we end up getting y prime of t over y is equal to 3e to the t, okay? So now that we have that, okay, let's now see if we can rewrite this y prime. So remember y prime of t, that technically just means find the derivative of the y function with respect to the t variable, okay? So we're going to simply rewrite our integral, okay? Now 1 over y times dy dt, all right? And then we're going to find now the integral with respect to t, okay? Since that's our variable inside of the parentheses there, okay? And then on the right side, do the same thing, integral 3e to the t, and then again with respect to t, okay? So we see then over here on the left side that dt's cancel out. So we just have the integral of 1 over y dy. And then on the right hand side, we can pull that 3 out, integral of e to the t dt. Okay. All right, so it was separable, right? We now have one side with nothing but y's, the other side with nothing but the variable t. Okay, so let's go ahead and find the integral. So here, the understood exponent on the y in the bottom there is just simply 1. So therefore, this is just the natural log of the absolute value of y. Then over on the right side, bring the 3 down. And then, of course, the integral of e to the t is just e to the t. And then since it's an indefinite integral, we'll go ahead and say plus c. Okay? All right, well, the goal is to try to, all right, get this as a function of y of t. Okay? That's what we want to do. So that means when we look over here on the right side, or sorry, on the left side, we see that we still have this ln right here, right? So we need to get rid of the ln. Well, we know the inverse of ln is the e, right? So how about we raise both sides, right? So have that e as the base, and then just take e to both sides, right? So make both sides as the exponential function, okay? So that means now we have just the absolute value of y over here, and then over here, we're just going to keep it exactly how we see it, okay? All right, well, since we have that absolute value, then we know anything inside of the absolute value could be positive, it could be negative. So therefore, if we drop the absolute value sign on the left side, then in front of the right side, we have to put a plus or minus e, 3 to the et plus c, okay? All right, so now the goal is to try and solve for this c, okay? Well, first of all, which one are we going to take, right? Are we going to take the plus or are we going to take the minus for this, okay? Well, what do we know, okay? We know that if we think about the exponential function e to the t, right? If we think about that, that's always a positive function, right? If you think about what the graph of that looks like, right? It's always going to fall above the x-axis, okay? Then we also have this condition, right? Your initial condition, y of 0, right? That has to be 1. So that means your t is 0 and then your y value is 1, okay? So that means if we plug in 0 into this function, so if we plug in 0 right here into this t, right? Let t be 0, what do we get, okay? Well, let's see. What do we get for the y? If we plug in that e3 e to the 0, right? Then what are we going to get? This e to the 0, anything to the 0 is 1. So e to the 3, and we know that this indeed is a positive number, okay? So therefore, we have to take the positive of this, okay? So y is equal to this e to the 3 et plus c, okay? So c is up there in the exponent. So now we need to solve for c, okay? So again, we're going to take that initial condition, okay? Our y sub 0 equal 1. Okay, so all we're going to do is simply let the y be the 1, okay, just like we said over here, and then let your t be the 0. So what do we get? 1 equal e to the 3 plus c, right? Well, now we have to figure out, okay, well, what must this c be, right, in order for this function to be equal to 1? Okay, well, if we want this to be equal to 1, right, well, we know that anything raised to the 0 power, right, is going to be 1. So that means that our 3 plus c must be equal to 0. So therefore, our c must be negative 3, okay? So therefore, since that we have our c, then we're now able to write what our function is, okay? So it's a function of the variable t, and we know that because that's the only variable we have there, so it's y of t is equal to e to the 3 et, and we can now say minus 3 because we now know what our c is equal to. And so there we go, okay? So we were able to find our function, okay? Our function for that equation using the given initial condition.